block elements. Periodic elements, the total elements classified into four categories: S block and P block, D block and A block. The elements majorly classified into four categories based on differentiating electron enter into valency orbitals. In S block elements, differentiating electron enter into S orbital, and P block elements, differentiating electron enter into P orbitals. In D block elements, differentiating electron enter into D orbitals. The general electron configuration of D block elements is n-1 D 1 to n ENS 1 or 2. D block elements. Okay, this is the general electron configurations. Next, D block elements further classified into four series. These are 3D, 4D, 5D and 6D series. In 3D series, first element is scandium, the last element is zinc. Scandium atomic number is 21, zinc atomic number is 30. 4D series start with yttrium, atomic number is 39, ended with cadmium 48. 5D series start with lanthanum and end with mercury, and the 6D series start with actinium, and the last element in 6D series is copernicium. The atomic number of lanthanum is 57, mercury is 80, actinium atomic number is 89, copernicium atomic number is 112. Okay, these are the four series are present in D block elements. Okay, scandium 21 to 30 is there, yttrium 39 to 48 is there. When we come to the 5D and 6D series, okay, just these are 10 elements, 10 elements and 10 elements and 10 elements. When we coming to the lanthanum series, when we coming to the 5D series, in between lanthanum to hafnium, lanthanum means, and again we should write like this: lanthanum 57 and hafnium 72. Okay, in between 57 to 71, the 14 F block elements are present. 14 F block elements are present. In between actinium to Rutherfordium, again 89 to and 104, 89 to 104, 14. These are the 4F series element, and these are the 5F series elements are present. 5F series element, 5F series. Okay, these 14 F block elements are named as lanthanides, and actinides, actinides. Next, when we coming to these atomic radius of scandium, zinc and yttrium to cadmium, lanthanum to mercury and actinium to copernicium, we should know about the electronic configuration of 3D series first. Electronic configuration of 3D elements. Electronic configuration. Electronic configuration of 3D series. 3D series. Scandium. Simple technique is there: scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Atomic numbers are 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. When you observe the atomic number 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, based on this, we can easily write the electronic configuration of 3D series first. Okay, 3D and 4S. 3D, 4S. 2, 2, 2, 2, 2, 2 is the common for all the elements up to copper. Okay, these two number is goes to 4S2. 4s2, and 1 is there, 1 is for D1, and 2, 3D2, and 4s2, 22, and 3D3, 4s2, 23, this is 22. Next, chromium, it is an exceptional case is there, that is 3D5 and 4s1. Next, manganese 25 again, 3D5 and 4s2, and iron 3D6, 4s2, 26, and cobalt 3d7, 4as2, 27. Next, coming to the nickel, 3d8 and 4s2, 28. And next exception case for copper, 3d10 and 4s1. Next, zinc 30, so 3d10, 4s2, 2 plus 10 is equal to 30. Okay, this is the general electronic configuration of D block elements. Anomalous electron configuration, that is the exceptional configuration for chromium and copper. Reason behind this: for chromium, it attains the half-filled electron configuration in 3d5 and 4s1, and when we come into the copper, it by abstracting the electron from s orbital to d orbital, it attains the completely filled electron configuration. This is half-filled, half-filled. This is completely filled electron configuration. Due to this reason, copper and chromium gain the different electron configuration than the expected electron configuration. Okay, this is about the simple electronic configuration. Okay, technique to write the simple electron configuration of 3D series from scandium to zinc, and 4D series also, 5D series also, and 6D series also follows the same rule. Some exceptions are there in any elements. Okay, electron configuration of 4D series. 4D series has 10 elements. Start with yttrium and with cadmium. Yttrium atomic number is 39, cadmium atomic number is 48. Yttrium 39, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium, palladium, silver, cadmium are present in 4D series. And in this series, only yttrium, zirconium, technetium, and cadmium follows the general electron configuration of 5s2, except these four elements, yttrium, zirconium, technetium, cadmium. All the elements follows the different electron configuration, exceptional electron configuration, that is 5s1 electronic configuration. When we come to the yttrium electron configuration, 39, atomic number is 39. After follows the krypton electron configuration follows the 4d1 and 5s2 electron configuration. Zirconium 4d2 and 5s2. 5s2 is there. When we come to the niobium, it is quite different from zirconium electron configuration, that is 4d4 and 5s1. This s1s electron transferred to 4d system and follows the 4d4 and 5s1. And also same like niobium, molybdenum also follow the same electron configuration, that is 4d5 and 5s1. When we come to the technetium, it follows the manganese electron configuration. It is one of the successive element of the manganese. Technetium electron configuration is krypton 4d5 and 5s2. And coming to ruthenium, it follows the exceptional electron configuration again like molybdenum. Ruthenium follows the electron configuration is 47 and 5s1. 5s1. These electron are transferred to d orbital system. And when we come to the rhodium also follows the same order, that is 48, 5s1. Palladium is quite different from these 9 elements. Palladium follows the different electron configuration compared to this ruthenium, rhodium, and molybdenum and niobium, that is 4d10 and 5s0. And silver, when we come to silver, it is one of the successive element of the copper. Copper as the electron configuration like 3d10 and 4s1, also same, and means silver also like follows the electron configuration like copper, that is 4d10 and 5s1. Cadmium, it is one of the successive element of zinc. Zinc has completely filled electron configuration, and also cadmium shows the same electron configuration like cadmium, that is zinc, that is 4d10 and 5s2. Okay, these are the technique to remember, to find out the and to write the electron configuration of 4D series, that is except yttrium, zirconium, and technetium and cadmium. All elements follow the different electron configuration, that is 4dn and 5s1 electron configuration. To write the 4D elements electron configuration, we should remember that yttrium, zirconium, technetium, cadmium electron configuration first. After that, we can easily write electron configuration of 10 4D series. The simple technique to write electron configuration. Compare with the 4D series, 5D series element shows the general electron configuration. There is no exceptional electron configuration except Rm. Except Rm. 5D series has 10 elements from lanthanum 57 to cadmium 80. In between lanthanum to hafnium, 14 elements are there. Lanthanum atomic number is 57. The general electron configuration is xenon 5d1 and 6s2. When we come into the hafnium electron configuration, okay, in between lanthanum to hafnium, 4 of electrons are entering into this system because lanthanum series is there in between lanthanum to hafnium. Okay, in between lanthanum to hafnium, 4 of orbital electrons are filled with 4 of orbital electron is completely filled. Next, when we come into the electron configuration of hafnium, the electron configuration started with 4f14, next 5d2 and 6s2 because 1, 2 and 2, 2. Next, tantalum electron configuration is 4f14, 5d3, 6s2. And tungsten electron configuration is 4f14, 5d4, 6s2. And radium electron configuration is 5d5, 6s2. Osmium electron configuration is 5d6, 6s2. Iridium electron configuration is 5d7, 6s2. Platinum electron configuration is 5d8, 6s2. Rm electron configuration is 5d10, 6s1. Cadmium electron configuration is 5d10, 6s2. This is the difference between 3d to 4d, 4d to 5d electronic configuration.